The topic for today is the effect of surface area, light, temperature, and catalyst on the rate of chemical reaction. Temperature, surface area, light, catalyst all affect the rate of chemical reaction. Effect of surface area, light, temperature, and catalyst on the rate of a reaction. The smaller the particles of reactants, the larger the surface area, and the faster the reaction. Powdered marble will have larger surface area, hence react faster than marble chips, which has a bigger size and smaller surface area. Larger particles, smaller particles. Marble chips, smaller surface area. Powdered marble, larger surface area. Smaller particles available for collision. More particles available for collision. Less contact with reacting particles. Greater contact with reacting particles. Light. Some reactions are influenced by light. Such reactions are known as photochemical reactions. The reaction between hydrogen and chlorine is explosive in bright sunlight, moderate in daylight, and negligible in the absence of light. Reactions influenced by light includes the reaction between methane and chlorine, the decomposition of hydrogen peroxide, photosynthesis in plants, conversion of silver halides to metallic silver used in photography. The reactant particle become activated by absorbing light energy and react rapidly. Temperature. When the temperature is increased, the particles acquire more kinetic energy and collide more frequently, which results in increase in the rate of reaction. When the temperature is decreased, the particles lose their kinetic energy, the frequency of collision is decreased, and the rate of reaction is reduced. Effect of catalyst. A catalyst alters the rate of reaction, but remains qualitatively and quantitatively unchanged at the end of the reaction. A catalyst increases the rate of reaction by lowering the activation energy of the reaction. The diagram represents uncatalyzed and catalyzed exothermic reaction process. As you can see that in the catalyzed process, the activation energy has been lowered. Some catalyzed reactions are hydrogen peroxide going into water and oxygen with manganese 4 oxide as the catalyst. Number 2, potassium trioxochlorate 5 decomposing to give potassium chloride plus oxygen with manganese 4 oxide as the catalyst. High heat is needed without a catalyst to decompose the potassium trioxochlorate 5. Moderate heat is needed to rapidly decompose the potassium trioxochlorate 5 with a catalyst. Examples. Number 1, methane plus chlorine giving chloromethane plus hydrogen chloride gas. The major factor that influences the rate of the reaction above is A. Catalyst, B. Temperature, C. Concentration, D. Light. The correct answer is option D. Light, because this reaction is a photochemical reaction. A cannot be the answer because there's no addition of a catalyst. B cannot be the answer because temperature has not been increased. And C cannot be the answer because there is no change in concentration. Number 2. A catalyst increases the rate of a chemical reaction by providing a path that A. raises the activation energy, B. increases the temperature, C. lowers the activation energy, and D. increases the concentration. The correct answer is option C, because a catalyst lowers the activation energy. Option A cannot be the answer because a catalyst does not raise the activation energy. Option B cannot be the answer because a catalyst does not increase the temperature. While option D cannot be the answer because a catalyst does not increase the concentration. Number 3. The efficiency of solid catalyst to increase reaction rates depends on its A. surface area, B. solubility, C. concentration, D. quantity. The correct answer is option A, because it depends on the surface area. Option B cannot be the answer because efficiency of a catalyst does not depend on solubility. The efficiency of a catalyst does not depend on concentration as well, so option C cannot be the answer. And the efficiency of a solid catalyst cannot depend on quantity because catalyst efficiency does not depend on the quantity.